This is Senior Algebra Section 7.4, adding and subtracting rational expressions. So, how do we add rational expressions when they have the different denominator? That means the bottoms are different here. So, we think about a regular fraction here. We think about least common denominators, rewriting it and stuff like that. So, it's an extension of what we've done before. So, if we've had something like 3/4 plus 5/6, I'm going to look to get a common denominator. Now, with numbers here, it's pretty easy. Oh, 4 and 6, we know that's going to be 12 here because we count 4, 8, 12, or 6. But remember, the other way we can do it is we can break 4 up. 4 can be written as 2 times 2. 6 can be written as 2 times 3. And the common denominator means the bottoms have to be the same. So if I look at the bottom here, on the bottom of the first one, I have 2 and 2. On the bottom of the second one, I have a 2 and a 3. So, if I look, the second one has a 3 in it, so that means the first one has to have a 3 in it as well. Remember, if I do it to the bottom, I have to do it to the top, and then the second one, since the first one has 2 2's, the second one has 2 2's. So that's that second step, rewriting each rational expression as an equivalent rational expression. So, the bottoms are the same, so I'm going to multiply the tops now. 3 and 3 is 9. And when I multiply 3, 2, and 2, I get 12. And then I get 10 over 12. And now, since the bottoms are the same, okay, and I rewrote it, now I can add the numerators together, add the tops, the bottom stays the same. So that's where I get the 19 over 12. Last thing I would look to do is to write it in lowest terms. In this case, there's nothing I can do there to simplify it. So we start in example 1, okay, and we look, what's x squared minus 1 made up of? How can I factor that? Well, that's made up of x plus 1 and x minus 1. So I look and I see, well, they have to have the same bottom here. So in the first one it has x plus 1 and x minus 1. In the second one it just has an x plus 1. So the second term is going to have an x minus 1 on the bottom. And of course, if it has it on the bottom, we have to multiply it to the top as well. When I do this, the 2x over x plus 1, x minus 1, that stays the same. The second one becomes negative 1 times x and negative 1 times 1. So I get x plus 1, x minus 1 on the top, and negative x plus 1 on the bottom, or on the top. When I put the tops together now, on the bottom I'm going to get x plus 1 and x minus 1. On the top, 2x minus x, well, that's just x plus 1. And now I look, can I simplify it any farther? In this case, I have x plus 1 on the top. I have x plus 1 on the bottom. They're being multiplied, so I can cross those out. What am I left with then? On the top, a 1. On the bottom, x minus 1. That's going to be my final answer there. In B, I'm going to start by factoring it. So I'm going to factor the bottoms for both of these. Top stays the same, 2x. Bottom, x plus 3, x plus 2. And for the second one, on the top stays the same. On the bottom, x squared, that's x and x. And then, let's see, a minus 3 and plus 2. So I think I'm going to have minus 1 and plus 3. Because I had to multiply to a negative 1 and add to 3 here. So now I look, they have to have the same bottoms here. So what do I have to add to the first one that's in the second one here? So the first one has to have an x minus 1 in it. If I look at the second one now, what do we have in the first one that's not in the second one? Well, the x plus 2. So we have to have an x plus 2 on the top and the bottom. I'm going to go ahead and multiply the tops out. The bottoms are going to stay as x minus 1, x plus 3, x plus 2. When I multiply the tops, I get 2x squared minus 2x. The bottoms stay the same. On the top of the second one, again, the bottoms are the same. I'm going to get x squared plus 1x, and 2x is 3x. And then 2 times 1 is 2 here. At this point, since the bottoms are the same, now I can combine the tops. So 2x squared plus x squared, that's 3x squared. Bottoms stay the same. Negative 2x and a positive 3x. That gives me a positive 1x. And then plus 2. At this point, I look, can I factor it? Well, since they're both plus here, there's no way I can add two numbers that multiply to 2, all with the 3 in there, and add to 1 here. So I am done. There's nothing else I can simplify there. In example 2, in A, so if I look at the bottoms in A, they're opposites, x minus 5 and 5 minus x. So instead of multiplying them together, I can just multiply one of them by negative 1. Now, it doesn't matter which one, could be either one. I'm going to multiply the second one. So the first one stays the same. When I multiply the second one, I get x minus 5 on the bottom, a positive x and a negative 5. And then a negative 2x plus 25 on the top. So now the bottoms are the same. I get x plus 25 all over x minus 5. In this case, I'm done. I cannot cross out the x's because it would have to have the whole thing because I'm adding there. And then the last one in B. So this one is a subtraction one. We'll deal with the subtraction at some point. You could do it right away, where you could distribute the negative to the top or the bottom. Or you could wait. We're going to wait a little bit here. We're going to factor the bottom, x minus 1, x minus 1. And then we're going to factor the bottom on the second one, x minus 1, x plus 1. So I look, what are they missing? What does the second one have that the first one doesn't? Oh, an x plus 1. So I'm going to have to multiply the first one by x plus 1 on the top and x plus 1 on the bottom. What does the first one have now that the second one doesn't? Oh, that has another x minus 1. So now I'm going to simplify the tops here. The bottoms are going to stay the same. On the top, 6x squared plus 6x. On the bottom, x plus 1, x minus 1, x minus 1. And then x times 1 is x, or 1 times negative 1 is negative 1 here. Now, how do I deal with that negative here? We're going to move it to the top. And the key in this is when you have that negative, it has to go to everything on the top. So that negative, I'm going to move to the top, and it has to go to everything. How do I show it goes to everything? Okay, I could put a negative 1 and then use parentheses to show that it goes to every part here. So there's the negative, and it goes to everything there. So what am I going to end up with? Plus, and then on the top of the right one, oh, I just distribute the negative. I'm going to get negative x plus 1. At this point now, just put your like terms together. Bottom stays the same. I'm adding the tops. 6x squared plus 5x plus 1. I look and see, can I factor it and get something that would cancel out? Now, I think I can factor this. 2x plus 1, 3x minus or plus 1. Yeah, that would work, but does that cancel anything out? In this case, it doesn't, so I can leave it like that. If something would cancel on the top and bottom, I would look to cancel it here. So the last thing here, on the bottom right-hand part of your paper, put your favorite movie. Put your favorite movie in the bottom right-hand corner.